Okay, this is the second part of video lecture 4. So we have a multiplexer with two input. The two input is D0 and D1, and we have one output Y here. So what multiplexer will do is actually chooses between two inputs of D0 or D1 because we have only two inputs. So the output Y here will choose if the S equal to 0, then the output here will choose D0. Okay, so the Y here will take the input D0, and then for this S equal to 1, then the Y here will take the output of 0, 1 here. So the output Y here will have a 0, 1 and 0, 1 like this. In gate level multiplexer design, for this equation Y equal to SD1 plus S bar D0, it will have in this gate level, if you have the inverter here, it will have the NMOS and PMOS, and if you have the NAND, you have a four transistors, and the rest. So if you plus 2 plus 4 plus 4 plus 2 2 and plus 4 and 2, you will have 20 transistors are needed for this type of gate level multiplexer design. Or the other way to design is using this. So there's many transistors are used here, so it will consume some power there, and we do not want that. We want to reduce the power consumed. So what should we do? When we can use transmission gate multiplexer. This is where the non-restoring multiplexer, where it use two transmission gate at once. What I mean is, this is one transmission gate and the other one is this transmission gate. So basically it has the PMOS, NMOS, PMOS and NMOS, four transistors at once. So what happen if we have S equal to 1? S equal to 1, then this one will be turned on, and S bar here will be turned off, 0 will be supplied here, and PMOS will be turned on. Then the transmission gate of this part will be on. So the Y output will have a the SD1, right? And then what if the S is equal to 0 here? Then this one, the PMOS here will be turned on, right? And S bar here will have a 1, and basically the NMOS here will be turned on. So the second part, the top part here of this transmission gate will be turned on. Then the Y will take the D0 output. So we can plus S bar with the D0. So basically this is what you have for equation Y equal to SD1 plus S bar D0 with 4 transistors. That is, you use 2 transmission gates at once. So you reduce numbers of transistors from 20 transistors to only 4. So you reduce the power consumption.